So now let's actually talking about solving these. So we're going to do that using Gauss-Jordan elimination. So this was founded by Carl Friedrich Gauss and Wilhelm Jordan. So the algorithm goes like this. The first thing we do is we find the first non-zero column. We're going to use the row operations to make the first entry in this column a 1. We'll use that by either interchanging the rows and/or scaling them. The second thing we'll do is use the replacement operation to get zeros in all the other entries of that column. We'll then move on to the next non-zero column. We'll use row operations to get a leading entry in the next row. Rather than the first, this time will be in the second row. We'll use the replacement operations to get zeros in all the other columns. And we'll just slowly repeat this process until we have the reduced row echelon form. So let's solve this system. So the first step is going to be to put this actually in the augmented matrix. So I have a -1, -5, -5, and then a 2. The second equation gives me 4 minus 5, 4, 19. The third is a 1, 5, minus 1, minus 20. So the first step would be to get a 1 in the first row, first column. I could do that in 2 different ways. I could switch the first and the third row, or what I'd rather do is multiply the first row by -1. That makes it 1, 5, 5, and then 2. The other 2 rows will still stay exactly the same as what they were previously. The next thing we want to do is to get zeros below that 1. So this time I'm going to leave the first column alone, first row alone, and deal with the other 2 rows. So I want to start by turning this into a 0. Using the replacement operation, I'm going to add a multiple of a row to another. So I need to think, what can I add to 4 to make it a 0? Well, -4. So I'm going to multiply the first row by -4 and then add the second row. That gives me a -4 plus 4 is 0. A -20 minus 5 is -25. -20 plus 4 is -16. -8 plus 19, should be a -2. Positive 8 plus 19 is 27. Now let's think about the third row. It's currently a -1. So I'm going to multiply the first row by -1 and add the second row. That gives me -1 plus 1 is 0. -5 plus 5 is 0. -5 minus 1 is -6. And -2, positive 2, minus 20 is -18. So now the first column looks exactly the way we want it to. And we're going to move on to the second column. This time, I want to get a 1 in the second row, second column. It's currently a 25. So in order to turn that into a 1, I need to multiply by -1 over 25. So I'm going to do -1 over 25 times row 2. That'll give me a 0, a 1, 16 over 25, and minus 27 over 25. Get a little more space. Now that we have that, we want to get zeros everywhere else in that column. The third row already has a 0, which is very helpful. So we only need to get a 0 in the first row, second column. So it's currently a 5. In order to get a -5, we're going to need to subtract -5 row 2 plus row 1. That gives me a 0 plus 1 is 0, a -5 plus 5 is 0. Negative 16 over 5 plus 5 is 9 over 5. And positive 27 over 5 plus 2 minus 2. I don't know why I keep writing a plus there. That should be a minus. Minus 2 is 17 over 5. So now the second column looks like it's supposed to. So let's do the third column. The first step is to get the 1. In the third row, third column, it's currently a negative 6. So in order to get a 1 there, I'm going to multiply the third column by negative 1 over 6. That turns this last entry into a 3. The first and second rows will currently stay the same. However, at this point you can already see what x3 should be. It should be 3. Well, what about everything else? Well, we're going to leave the third row alone, and we're going to work on getting zeros above that last 1. So I'll start with the top one. It's currently a 9 over 5, so I need to subtract 9 over 5. Row 3 plus row 1. 0 plus 1 is 0. 0 plus 0 is 0. Negative 9 over 5 plus 9 over 5 is 0. And then 3 times negative 9 over 5 plus 17 over 5 gives me negative 2. I also need a 0 in this last spot. It's currently 16 over 25. So this time I'll multiply the third row by negative 16 over 25 and add it to the first row, or the second row, rather. So negative 3 times negative 16 over 5 minus 27 over 5 is negative 3. So the final answer is negative 2, negative 3, 3. So this one may have looked really bad, especially with the fractions over the 25, but in the end, we have a nice number answer. Let's do one more example. So we'll start by putting this into the matrix form. I have 1x1 minus 1x2 minus 2x3 is equal to minus 6. 3x1 plus 2x2, since there's no x3 term, that becomes a 0, and then minus 25. The last one, negative 4x1 plus 1x2 minus 1x3 is equal to 12. So the first step is usually to get a 1 in the first row, first column. We already have that. So we get to skip to now the second step. Get the zeros below that 1. Let's start with the first one. It's currently a 3, so I need to subtract 3, row 1 plus row 2. Negative 3 plus 0 is 0. Positive 3 plus 2 is 5. 6 plus 0 is 6. And then 18 minus 25 is negative 7. To work on the third one, it's currently a negative 4, so I'll add 4. 4 row 1 plus row 3. So that's 4 minus 4 is 0. Negative 4 plus 1 is negative 3. Negative 8 minus 1 is negative 9. And negative 24 minus 12 is negative 12. So we have our first column. And now we want to work on the second column. You'll notice if I multiply the second column by 1 over 5, I'm going to be dealing with fractions like in the last example. However, if you watch what you're doing and watch your other rows, there is a better option. So this time, instead of multiplying the second row by 1 over 5, I'm going to start by switching rows 2 and 3. So now I have 0, negative 3, negative 9, negative 12, and 0, 5, 6, minus 7. So now I'll worry about getting that 1. When I do that, the first row will stay the same, and my new third row will stay the same. If I want to turn a negative 3 into a 1, I'm going to multiply the second row by negative 1/3. That's going to give me a 0, 1, 3, 4. So by switching these rows first, I'm eliminating the need for fractions. So now let's do the next step. Let's get zeros above and below that 1. So this algorithm has a really nice property of once we do it, once I get the first column, the row operations are not going to change that column. So it makes it very nice. To get this top 0, I can just see that I can add row 2 plus row 1. That gives me 1 plus 0 is 0, negative 1 plus 1 is 1, negative 2 plus 3 is 1, and negative 6 plus 4 is negative 2. The third row has a 5, so I'm going to do negative 5, row 2 plus row 3. That gives me a negative 5 plus 5 is 0, negative 15 plus 6 is negative 9, negative 20 minus 7 is negative 27. Now we'll worry about the third column. And we start by getting the 1. So for this one, that entry is currently a negative 9. So in order to turn a negative 9 into a 1, I need to multiply by negative 1 over 9. So that gives me a positive 3 in this last spot. Now we just need to worry about the zeros above that 1. Everything else has been set. That's the only thing we're missing. So let's start with the top one. It's currently a 1. So in order to turn a 1 into a 0, I need to subtract 1. So I'm going to do negative row 3 plus row 1. Because negative 1 plus 1 is 0. Negative 3 minus 2 is negative 5. The second 0 is currently a 3, so I'll do minus 3 row 3 plus row 2. That gives me negative 3 plus 3 is 0, and negative 9 plus 4 is negative 5. So for this one, my solution is negative 5, 3.